ludzi z innych
Tak,
krajów.
tak. Po angielsku, jasne, tak.
Okay, guys. So I think it's time to kick off. It's already 10 past. As far as I am aware, it's already recording, right? So yeah, so let's kick off. So as the title suggests, we will be talking about energy independence. And I hope the public here will be actively engaged in the conversation in this presentation too. So what it means, I think the first question is what it means, because what it means to be independent in terms of energy. First of all, I have to start with this dark thought. I don't believe we can be independent, because any technology that we will ever use will be likely produced, even if we will do something DIY, it will be likely produced somewhere else originally, so melted in some big steel mill or so. But the main thing is a total independence or total freedom. In my opinion, it's not really possible. So I think it's a matter of the lesser evil in that case. So, and on that note, I will start. So today's workshop will focus mainly on solar technology. The poll that I organized, most of people wanted gas storage. There was one person who asked about solar, but I think it's because of the expertise and because the widely used and a couple of other things that I will mention. I think it's one of the best candidates for independence, if we can call it independence. Yeah. So, sorry guys, my mouse is very sensitive today. So this is a brief. This is what we will talk about today. So where we are now, we'll include some theory, some practice, because I basically want to show you why I think it is a good option too. In my opinion, it is really easy to adapt to basically do it on your own as well. And affordability, and then some order, because in my opinion, gas is a perfect combination in terms of energy, in that mix of energy that we would need to be more or less independent. Yeah. So okay. So So there, as you probably are aware, there are different sources, different people predict different things, and there is not a single same prediction about what in terms of what energy mix or what energy source will prevail in the future. But if you look at a couple of sides, you see basically one thing: solar will dominate. Solar energy will shortly dominate the energy industry in terms of electricity generation. And we need to focus on this part. Like in terms of transport, I don't think that's the case. In terms of some industrial usage, no, that's definitely not the case, in my opinion, of course. And so solar will dominate the electricity generation, but that would be mostly for household use. So yeah. Before we go to the next one, I just want to mention one thing. If you're looking at this graph here, you might be kind of thinking, well, if renewables, because it's not only solar, it's wind and geothermal and hydro, biomass, yeah, if you can consider this renewable. And if the renewables will prevail, if they will basically consist the majority of energy production in the near future, then we should sleep well. I mean, we shouldn't have any major issues with this, any worries in terms of carbon or other issues, like because it's not only carbon, right? It's carbon is only a part. I will basically focus on carbon here, on carbon CO2, but because it's easy to find information, it's easy to present as well this information. But I think we are all aware it's not only about carbon emissions, pollution, heavy metals, sulfur, methane. There is many other pollutants or many other issues. But as I said, this one is the easiest to measure at that stage, and so I'll use this in my presentation, right? But I'm not blind to other issues. I just want to explain why carbon. Yeah. So this is a carbon prediction, carbon emissions prediction for. There is basically three scenarios, and I just want to mention one thing. I'm using the sources I'm using. I can distribute them in the end. You can verify it on your own. As I said, there are different predictions, but they are all generally they are all the same. So even though it might not be accurate exactly as to other sources you might research, this is the general prediction. So as you can see, the CO2 emissions will continue to rise. Even in the best case scenario, even though the solar, as you can see here, in 2040, the renewables will consist of majority of energy mix. But up to 2070, in the best case scenario, we will still emit more CO2 to atmosphere than we ever did before. Because the real problem, the main thing is, it's not as much about what we use. It is more about the other factors. So the population, the lifestyle choices, the things we do with our lives. Yeah. So our energy source is one thing, but how we exploit, how we use the energy is actually the major contributing factor, right? Sorry again, but still, why am I advocating for solar? I am and I'm not. I believe I believe this could be a good source if you're doing this in the right place, in the right conditions. So for example, I'm living in Ireland, and I'm using solar to power my house. I'll show you my house on next couple of slides. Is it the best energy source I can use? At the moment, yes, because of the limitations of the place where I am. I'm living off grid, by the way, and yeah, by choice, but we'll get to that later. So as you can see, some places are better, more suitable to in terms of solar energy usage, and you can see that the difference is actually quite. I mean, it is massive. So it's basically what I have in Dublin is basically half of what the Iberian Peninsula has, or Turkey, or Italy. It's only half, yet I'm still living where I'm living for 2 years and without major energy issues. And I'm not supplementing this really. I did for a short moment, and that was a wind turbine that I made, but this will be a subject of the next presentation. So, today we will focus on solar. So again, I think solar, in some circumstances, in some places, it might be a good solution. Might produce the electricity Imagine one situation. There is a million ways to do one thing. So if you're installing a solar array in your garden, for example, you're living in Scotland. I'd say one of the Scotland mountains, one of the most cloudy, rainy, and basically north-oriented place in Europe or Scandinavia, for that example. And if you're placing solar array in your garden, covering, so let's say you need to remove some trees, so on your farm, for example, because I've seen those types of installations. If you need to remove a forest to put a solar array in Scotland or in Scandinavia, that's insane. I mean, that makes no sense. And if you're bringing the materials, the solar panels from China, which is often the case because they are cheaper, I mean, what's the carbon footprint of this? So that's a consideration. But you can do a contrary. You can do this in a places where it makes sense in a way that makes sense, and I will talk about it shortly. Sorry, guys, it's really sensitive mouse. So according to the science, right? Sorry, 1 second. Natka? No, sorry, that's my wife. I was thinking she's not. Apologies. We'll cut this later. According to a different resources I found.
Krzychu, I am very sorry. Can I have just one technical thing? Because I think that maybe you should speak closer to the microphone, because I've got a really like these interruptions from time to time.
Do you think this is microphone or this
I
is
think
maybe...
that it maybe the distance between you and the microphone. I don't know, but it's kind of breaking from time to time. So yeah,
it might be breaking because of the internet, I think.
Okay.
But is it any louder now, for example?
It's louder, yes, but
Okay,
I don't know about the quality.
Yeah, because the microphone is in my headphones. So
all right, sorry for the interruption.
No. Actually, one thing I should ask before: can you hear me correctly? And am I speaking too fast, or maybe I'm mumbling? Just if you have any, yeah, all good. Okay, so thanks for the input anyway. Yeah, so coming back, according to the science, this is what the footprint of solar will be or is at the moment. 40 grams of CO2 per each kilowatt of energy produced. Comparing to carbon, looks great. Carbon is basically a kilo of coal per each kilowatt. So it's like it's a win, I would say. Comparing to other sources like wind or nuclear, it might look like not the best solution, but as I said, I think it's more of a matter. It's more of a matter if 1 second. Actually, sorry guys, Natka. Sorry. It's more of a matter of how we do it and where. So, and there is also another thing. In terms of coal plants exist. This technology is actually really old. It's over 100 years. I'm not too sure exactly how much. I'm not a scientist. I've never went that deep, but it's an old technology. Solar, on the other hand, is not, maybe it's not a discovery of 21st century, but it's still quite new, especially in terms of recycling. According to this, the recycling consists up to 20% of carbon emissions or carbon footprint of solar panel, of solar power. It is still in its infancy. There's only 5% of solar panels are recyclable or being recycled at that stage, where I'm sure we can do better than that. Another thing, the extraction of materials, the production itself consumes basically the majority of it, right? So, but we can still do better than that. That's what I hope anyway. In terms of power generation and maintenance, I would say this is basically non-existent in a lot of cases. Here you can see this is actually, I can't see because it says here that it's about 20%, up to 25. I believe this could be close to zero in some cases, in cases where you're doing this for yourself and by yourself. So yeah, so 40 grams of carbon emissions, carbon footprint, but I think it can be much lower than that actually. So I think it is competitive to other energy sources. Okay, yeah, but one thing I probably said that before, but I want to mention, I don't believe in clean energy. The green energy, the way the corporations or politicians are selling it, it's wrong. We need to emphasize on that. It is wrong. It's a lesser evil. That's all it is. However, yeah, so this slide attempts to show you that it can be done differently. Solar, in some cases, solar can be I would say I should say it wouldn't be a zero carbon material, but it would be close. Imagine a lot of houses in Poland, a lot of houses in Europe. That might not be the case in Ireland or Portugal, but a lot of houses in mainland Europe are covered with processed steel, so steel sheets. And so you need steel, you need to melt it, you need steel factories to produce that steel, you need chemicals, you need paint, a lot of chemicals and heavy metals in it as well. So in order to make such a roofing material, you need to actually involve a lot of materials, and the carbon footprint is massive. I didn't prepare that part, so I'm not too sure what's the exact carbon footprint of, for example, metal roofing material that, as I said, is very popular in Poland, for example, or in mainland Europe, like Germany. But I believe it's quite massive, it's quite heavy, and as I said, it's painted with quite toxic, rich in heavy metals paints. So why not consider it? Why not try to implement something like this? Something like putting a solar panels instead of the actual roofing material. Another thing, the weight of solar panel per square meter is 12.5 kilograms, which is actually much less than typical ceramic tile roof that you have in Portugal, for example. Which means if it's lighter, the whole structure, the construction of the house wouldn't require so much wood or another building material, which gives us cost benefits too. But you might think I sound like a, a seller. No, I'm just. This is how I think thinking can improve the way we source our energy, we get our energy, and yeah. So as you can see here, there is a couple of examples. In places where the sun is basically like Portugal, when the sun is so strong that it can actually burn plants, placing a solar array might actually make sense. I'm not saying this is the best way. I think there are obviously better, like permacultural ways of doing things, but it might be still better than leaving plants on their own and letting the water evaporate. So that's one thing. And another, a roof for animals. So let's say in that case, I mean the picture tells all. Guys, would you have any questions so far? And by the way, I forgot to speak to microphone. Chris?
I would have, yes, I would have one question because it was the previous slide, and could you explain it was previous or maybe two slides before? Can you show what was the? Yeah, what is that? Because for me it's very confusing, the upstream process, operational process, and downstream processes. Could you explain them a bit? Because I don't understand, the whole structure here.
Yeah. So okay. So in any, let me just. I'm trying to actually move so I can look at what I'm saying. So yeah. So in every the way the scientists measure carbon footprint is they divided this they try to basically cover all the stages. So the first stage is the place before any production actually happens. So this is the measuring of carbon footprint before any electricity is actually produced, in which in terms of solar is very high. As you can see, it's up to 70%. So the solar before a solar panel generate even a single kilowatt of energy, it has already reached about 70% of its carbon footprint, right? In terms of coal, it's very low. Those plants, they are basically there for, I don't know, maybe not 100 years, but for a long time, right? They don't decommission them out of blue. So for coal, it's very low. For I don't have the breakdown for all, but solar has actually one of the highest, right? In terms of before the energy being generated. Now the second part is about the maintenance. So the maintenance that has to happen in order for a solar plant to be operational. And this is one of the places where I actually disagree. I have solar panels only for 2 years, but I know people who have solar panels for around 10 years now. Well, the only maintenance that was involved was basically a bucket of water and just clean it sometimes because it get dusty and in the summertime. That is really all. In terms of maintenance on factory scale, it's a little bit different, right? It involves transport. So a company has to come, connect water, and wash them. So there is maintenance, yeah, but there might in case of living off grid, I'd say that value is basically zero. Yeah, so maybe cables age with time. You might need to replace cable, but that's unlikely as well. I haven't heard about anyone who had to replace a cable unless there was a storm. I'm sure, So yeah, I think that covers it. But if you will have any other questions, I mean, or if you disagree with something, please speak up. Yeah, so because this is a workshop, I want to show you another reason I believe why solar makes sense. So, as I said, we'll do some summary in the end, but one of the reasons I believe it is a viable option for for energy independence is because you can do it alone. And of course, there is some safety considerations. So you need to have some minimum knowledge of operating with power. But in general, I believe everybody can do it, really. I learned it when I did it on my own project. Then I did it for some other people who were maybe skeptical about the complexity. But I believe it is really simple. So basically, it consists of few elements. All those elements, they come quite ready. So you basically, the connectors, even the things like connectors, it's basically plug and play. So the complexity isn't there. You can do, okay, this will be maybe a bit generous, but I did an installation about 3-4 weeks ago. And so from starting to finish, it took 4.5 hours. And okay, I knew what I'm doing. I did this before. If you need to maybe read about this before, or if you need to prepare, or if you're not sure, it might take longer, but I don't believe it can take more than a day. So imagine you can basically prepare. You can do this in a day. That's all. That's as simple as that. Of course, there is some knowledge that you might need to gain before you do that, but I think it is really straightforward, even for non-technical people. So I'll attempt to briefly explain few things, few considerations before, let's say, an attempt of making such an installation. There is basically two ways you can do. You can connect solar panels, solar array. One is in series and one is in parallel. And each of those solutions have their own advantages and disadvantages, pros and cons, basically, right? Sorry, those words are difficult. Pros and cons. So I'm usually using the first way, which is parallel. So you connect minus to minus and plus to plus. You'll get the total power. So the power from each panel adds up. So if your panel is 100 watts, your another panel is 100 watts. In that scenario here on the top, that scenario will give you 200 watts of power. Now, each panel has its voltage. So the typical nominal voltage of a solar panel would be about 35 to 40 volts. So in parallel, when we connect panels in parallel, the power, the amps, power is measured in amps, right? So the power adds up with each panel. However, the voltage stays the same. So for example, if this is 40 volts, then it doesn't matter how many of them you connect in parallel, you will still have 40 volts. In some cases, okay, so maybe I'll just mention this part first. So this is a controller. So when you're doing this kind of system, you're basically simply connecting cables that they are there, right? When you're buying solar panels, you basically have those cables, those connections. All you need to do is basically connect them. And as I said, those are the only things that you need to know before which way you will connect them, which way you want to connect them, right? And why would you want to connect them this way? Apart from that, there isn't much else. You can correct me because maybe you might have actually some questions, or if you have really no idea how electricity works, But this is my this is how I see things, right? For me, the first day that I got my hands on it, I was thinking, oh my God, can't be so easy. You just connect cable from one place to another. I mean, you have clear instructions how to do it. Those connections, you don't need to make them as well. They quite often come ready. It's really hard to make a mistake. Although I know it is possible, right? So yeah. So anyhow, parallel. We have 40 volts coming from our array. Let's say we have multiple panels. That's going through charge controller. Each charge controller has a range of volts that it's working well with. So this would be the first thing, right? If we want to, and amps as well, right? So for example, my one is 30 amps. So what it means I can connect 10 panels and each will give me, let's say, 10 amps, but I still can't put more than 30 amps in my battery. So what's the point in buying 10 panels, right? Well, we'll get back to that. Because yeah, in the winter it might be different when the sun's angle and the sun's strength is not as strong, right? Anyhow, so in terms of voltage, I'll just go back to voltage for a moment. I hope this is not. I hope my thoughts are actually make sense and you're still following. Anyhow, the mentioned 40 volts. 40 volts. As you know, in our sockets we have 220, 240 volts. So in order to get that, we need something called power inverter, right? Here it says optional. Well, it is optional because you can, quite a lot of systems that I'm using on the boat, for example, I'm living on the boat. By the way, I'll show you something. Are 12 volt systems. So lights, pumps, you can basically buy all that you can run on 12 volt system. But quite often those tools or this equipment is more expensive. So for example, 12 volt fridge costs crazy money. So it's actually easier to buy a power inverter and then basically use the 220 volts that you are used to, because everything works in the households, everything works on 220, right? So again, you have 40 volts here. You're basically you have charge controller and you have a battery. Your battery, the standard battery is a 12 volt battery, right? Consisting of few cells. But I would say the typical car battery, because we can use a car battery without any issues, would be 12 volt. It's a good idea to scale this up because if you're converting 12 volts to 220 volts, it creates quite a lot of resistance, right? Imagine you want to remove some power, let's say 1000 watts of power from the battery, but first the inverter needs to transform this power into a different voltage, much higher voltage. Yeah, as I said, that creates a lot of resistance that can make the cables hot, that can basically burn the inverter and can cause issues. So in some cases, well, in general, if there's the bigger system you're building, the bigger voltage would be required, right? So 24 volts would be a better idea, or even 48 volts. And then you might see why you would like to connect some of the strings of solar panels in series in order to boost up this voltage, right? So, because that's what connections in series do. So basically you connect minus to plus and plus to minus. You're getting the same amount of power. So let's say in that case, the lower panel in the series connection would have 100 watts, the other one 100 watts too, but they will give you 100 watts also. So you're not getting the power doesn't add up, but the voltage adds up. So if the nominal power voltage here would be 40, they would give you basically 80 volts, which would be, again, it matters what types of battery you're using, but it would make it easier for the inverter to actually transform that energy without any losses, right? So without all that resistance. Resistance matters because of the cables. You need to use thicker cables. So for example, I'm using 12 volt battery system at the moment, and I wanted my cables as short as possible because they are expensive and because they are actually, sorry guys, I think I have a visitor. Could you just give me a second? Apologies. Apologies. So yeah, yeah, it's kind of crazy. I haven't told my friends I'm doing this, and yeah, it just came. But no, but that's not a problem. So look, connection in series, yeah, it is quite commonly used in on-grid connections as it's basically it wouldn't be as useful in off-grid as much as in on-grid. In off-grid, they try to maximize the voltage as the charge controllers for on-grid systems are a bit different. They work better in higher voltage. For off-grid systems, parallel connection makes more sense, right? As I said, the typical voltage of 400, let's say 400 watts solar panel would be 40 volts. If you have 24 volts battery system and then the controller that works well with that range, then you wouldn't have any issues using a power inverter, let's say 3000, 4000 watts of power. So yeah, so look, I'm not too sure how far we should take this, how deep we need to break this down, but I hope there will be some follow-up questions, and I hope you will you understood. I hope it was clear enough, because I said it is very simple, and I started to talk about watts and volts, but it is really simple. It is basic math, and then I think it's actually you can enjoy doing this as well. So to sum up, this is the list of elements that you would need to create your own. So solar panels, charge controllers, a battery, DC to AC inverter, which is the power inverter that I mentioned, and of course fuse, circuit breaker, and cables. And that might sound like okay, there is some other elements I need to include which you didn't mention, but there is one simple rule to include fuses and circuit breakers. So basically, between every element, like between solar panel and charge controller, or between charge controller and battery, so between every element in this diagram, we should have a circuit breaker and a fuse. And there is obviously security reasons, but also if you want to replace one of the elements, you don't need to unplug the cables. You can basically, well, you need to unplug the cables, but you can safely. You don't need to worry about. You can do it during the day, for example, when the solar is generating power. You're just switching closing the circuit, and you can replace the given element, right? There is one thing to know though. And for me, the major drawback of solar is the fact that we need to use the batteries unless we are connected to grid. But in this presentation, I'm focusing on independence, which in my case, the connection to grid is not relevant, right? So hence this, because there are other ways of doing this. You wouldn't need the batteries if you're connected to grid, but yeah, that's not the case here, right? Okay. So what else? So yeah, another slide of building it. As I said, in my opinion, it is simple. In my opinion, everyone can do it, and everyone can do it quite fast. Obviously, there are some considerations. Like you need to have a basic idea of, let's say, you need to have a multimeter, for example, for that instance. I said you only need tools you can find at home, but in fact, you need a multimeter to verify if everything is fine. Although you might get away without it, right? Because your controller is basically telling you how many volts are coming. Your controller is basically telling you once you connect solar to controller, it basically tells you what's happening, right? You have a screen, and this screen basically tells you all the stuff. But you need to remember a few things. So, for example, the controller needs to be connected to the batteries first. You'll get this information in every kit or everywhere where you buy every provider is mentioning this, but still you need to remember that. So solar and batteries, charge controller and the batteries need to be connected first. Then you connect solar panels and power inverter. Not the second, that step can be done whichever way you want. It's just that one thing. Batteries and solar controller, charge controller, they need to be connected first together. Yeah, so that's an example. Actually, this picture here is kind of, I'd say, the best example I found that illustrates all the elements that such an installation would have. Apart from this BT1 module, I don't think that's relevant here. This is just another fancy way to see what's happening without being physically in this place, right? So you can basically mount it in another place of your house, and you can see it, but you don't need that, right? Okay, so guys, I'll stop here for a moment. So would you have any questions so far? Do you disagree with something as well? Do you think, is this clear? You might actually say, Chris, that makes no sense. I didn't understand, and I don't think it's easy. I don't think anyone can do it in 4 hours. I'm not, look, just give me some feedback at that stage, and we can move on. And can you actually hear me?
Yeah, this time I could hear you well, and for me it's not really easy because it's the first time when I actually understood the difference between parallel and serial in this application. But you know, man, I was in a technical school, so I think that okay, I can follow. I think that it's not easy for people. I think that it's very risky to improvise with it. Do you know anyone who actually did it without any proper technical school? I mean, you know, I wouldn't care that much because I would get, yeah.
Yeah,
Okay.
I do. Yeah. So basically, as you can see on the picture, this is the place where I'm actually. I don't know how to say this. I'm talking from, right? So that's my house at the moment. It's a boat, and there is a lot of other boats around me. You can't see it on this picture, and I would say one thing. I like I really like my neighbors. Some of them are really not technical people. I would say the reality, the life pushed them into a place where they are now, and in some cases they simply haven't got any money to pay for a professional installation. They did themselves. I know at least 3 cases like this where a woman who had no prior technical knowledge did the solar panels on her own. Well, I know one, but there is two other guys. So she basically did this on her own boat. I wouldn't say this it was the best system, the best build or best considered build I've seen, but it works. It works and it's safe. It's small as well. I mean, it's basically one panel connected to a controller and the battery. That's all it is. So yes, I think maybe not. You might not get that impression after this, but if you would have all the elements, I mean, it is even hard to connect it wrong because the end bits are designed to. Once you know how you want to connect, if it's a parallel or series, and you can read about it, then it's really hard to make a mistake. Or it is just. But okay, I understand. You know, some people might have different opinions on this, right? Anyhow, another thing I want to mention, a lot of people are saying, but is it actually worth it? I mean, there are days you're not getting any power, or well, it's not true. You're always getting something. Sometimes it's much less than you would like to have. Sometimes it's more than you want to have. Yes, it is. It's not stable, right? That's for sure. But this picture was taken this morning. Well, that was actually not morning. It was 12. As you can see, I have a tree opposite to my boat, and that tree is really massive, and it's basically covering most of my panels. And it's basically October, right? Yeah, it's October, 1st of October today, and I'm still, even though we don't get much, like especially this summer was terrible, and we don't get much sun. I'm still running all I need to run on basically two solar panels, because the other two are not fully functioning. This is something I got from a friend for free. He was just getting rid of them. They are broken physically, like, because they were blown away. They weren't connected properly. But anyhow, that's not the topic here. So yeah. So what I'm trying to say, I believe it is safe. I believe it is easy, but this is my personal opinion, and it is possible. First of all, to use this type of power and to be able to survive, live using this type of power. Obviously, this is not all, right? So the last bit that I want to kind of highlight here as well. It is all about how you use energy, right? We have a fridge here. We have iron. We have a lot of typical equipment, but we also have things that we wouldn't need in a house. So, for example, because it's a boat, I need to pump the water, or I need to use water filters. So I need to use pumps to push water through filters. I have an ozonator to purify the water, which is using electricity as well. So apart from normal equipment, and of course I'm using laptops, I'm working from home quite often, so I need to charge my equipment too, and I'm making it. So yeah, but I know this is maybe a bit different in every case. So let's check what the official numbers are saying. So apparently, a typical person here, now that would be in Ireland, right? Because I did that a bit based on Irish numbers. Typical person in Ireland is using about 3 to 5 kilowatts of energy per day. So comparing to our usage, me and my wife, we are using about 1 to 2 kilowatts, and I feel this is that restriction, the difference. Well, we are energy aware, but that restriction, I would say, came also from the fact that we are living, but that we are using what we have, right? We don't have any other options. We are not connected to the grid. The engine is not working at the moment. I can't charge for a long time, actually. I can't charge the batteries with this. So this is my sole source of power, and so hence the usage is low. And the way I'm using stuff is different. So, for example, if I want to, I don't know, wash my clothes in the washing machine, I need to think. I need to think when. So, for example, I have a good day, I can wash my clothes. But if it's raining for a week, you know. So yeah, there is that. I just wanted to kind of mention also this graph I found. That's not the only one, as I said. I tried to find the sources. I tried to find. You can replicate it as well. So basically, but this is not nothing new. I mean, I'm not inventing the wheel here. The typical household in Nigeria is using 570 kilowatts of energy per year. That's basically what I'm using at the moment. But if you look at Canada or USA, the daily usage is, I think, how is that even possible? What those people are, I can't understand, to be honest. Anyhow, that's the values I found in at least two different places. So does it make sense to do it, to install a solar panel or a solar array, solar system? I think it does. So if you look at the energy, we already talked about the let's say the part of how you can use the solar panels differently. So, for example, to create a roof for your house, or to create something else that you need to create, I don't know, some place for your car or anything else. So we covered that bit. We looked at the carbon footprint, which is apparently significantly lower. Now we look at from financial perspective. So apparently, so a typical house here, and I was talking to two families before today, actually, just before I finished this presentation. So this standard usage here, they reported something lower than that. So basically between 2 and 3 kilowatts. That would be the median between them. And so is it worth it? So even the 2-3 kilowatts per year, that's from some Irish energy website. The estimated cost, and I think that website actually wasn't the newest. The news here weren't the most actual. Reports that it should be between 1,200 or 1,000, maybe 2,000 euro. This would be a typical household electricity bill. So is it worth it? I mean, I'm living here 2 years. I haven't replaced a single bit. I know some people who are living this way for, as I said, it's maybe not 10 years, but it's close to that. And they are in the same situation. They haven't replaced a single thing. So how much, if you I have built the system I've built costed me about 1,200 euro. But I know if I'd like to have a bit if I wanted to be a bit better, it would be about 2, maybe 3,000 euro if I want to expand a bit. So does it make sense? Yeah, I believe it does. I believe there is a lot of ways you can do it, and it really makes sense. As you can see, even the financial reason is there. In my case, well, I didn't have any option, but even if I would have, I would still consider doing this. My major drawback here is the battery. So, but not even the price of the battery, because I included the price. And the amount, the 1,200 I paid, was with the battery, but the ecological cost of the battery would be my biggest concern. But there is a hope, right? So I believe the battery, I believe this could change, right? So there are talks now about iron flow batteries or some other batteries, which would depend less on the critical minerals, rare earth minerals, maybe less on how badly mined they are. Because, for example, the typical battery, the car battery, lead acid battery, according to numbers, they are 95% recyclable. So which means, I mean, I'm talking about the whole thing. So even the plastic around it, the lead in the batteries is close to 97%. Those are the numbers I found, right? So I'm based. I'm based. Yeah. So that's what I can. That's what I believe. But if that's true, then it might mean that we don't need to necessarily mine more to make more batteries, which would make it even more greener, right? So yeah, so I believe it it makes sense, and I don't want to I don't as I said I don't want to come out as a person who's trying to sell something, but this is just an example. This is a let's say one of the kits, million kits you can find on the internet, and 3,000 watts. So something that even for a typical household, this should make it. Um, uh, it's just an example, as I said, but it has all, right? And it's about, I'm not too sure, 3,300, maybe 3,400 euro. I know this is a lot of money, but as I said, if you're thinking about this in a way that you are actually independent and that you are saving in the end, and that you will actually learn something new as well, I think it answers that question for me. So I'm not too sure if I convinced anyone else, but it makes sense, right? Okay, but I think the biggest issue, apart from the batteries, the biggest issue that we face in terms of solar is those days. So, for example, you have a farm, you have a house, and you don't want to worry that much about your energy. So, let's say winter time, especially is tough. December, those short days, rainy. So, like in my opinion, November, December, and January are basically the months where I'm really watching the battery levels, right? But there is a solution for that as well, especially if you have land, garden, if you have space. I'm a bit limited here. However, back a couple of years ago, I did some small projects. We will not be talking about this today. I just want to basically mention this only. So it was about gas, right? So you are probably all aware about biogas, or if you are not, it is a really interesting topic. Yeah, so there might be a time when your solar array wouldn't be enough. I agree with this. It is intermittent energy source. Um, you can try to fix it with building a bigger battery, but this is not what I recommend. So in my opinion, there is another way. There is another way around it, and it is actually gas. Um, so biogas, a really cool thing. It operates basically on waste from your toilet. If you have compostable toilet, I have compostable toilet. Uh, Food scraps, like how much of this stuff we are actually throwing away. And what happens in most of cases, it rots somewhere and it generates methane. Methane is actually 25 times more, well, not more pollutant, but 25 times worse in terms of warming capabilities than CO2. So if we can actually prevent this methane from emitting, if we can, funny enough, if we burn it, it is actually much better because the some of the particles that are created by burning is CO2, which basically means we're removing some energy that would be otherwise used as a to basically heat up the planet, right? I know some people doesn't believe this, as Chris mentioned in his hero's journey last time. This for some people, this is for some of us as well. This is a hoax, but I agree with Chris on the same in that place. I think most of people believe this is a hoax, not based on scientific data, but based on the fact that some rich people are trying to make some money on it. And yeah, I think it's as simple as that. Maybe not, but that's my belief again. So I think gas. But okay, we have gas. What else? We need a generator, and we need to feed that gas to the generator. Okay, but I will kind of stop here. I just want to show you another, I think, maybe even cooler, maybe not, depends, source of gas. Because this is biogas, right? This is gas made from organic matter. But we have also another source of gas that was previously quite widely used, especially in the hard times, you can say, during World War I, in Poland, in Germany, I'd say much of continental Europe. Most cars were actually running on wood gas. So yeah, it's something you can buy, or it's something you can build. And I don't want to dwell too long about it, because I would actually like to do a project, and I would like to show you as well how this works. But instead of showing you some pictures, I'd like to actually build one, because in terms of methane, in terms of bio-waste gas, I already did a project. It was even simpler than that thing on the picture. It was basically a barrel where I put stuff. It is really simple. And it worked. It generated the gas I wanted. I was able to put that gas in a tube, motorcycle tube, and burn it. But it was basically an experiment, and I wanted to contain my organic waste also and see what I can do with it. So it was just a project. I never really did generated any energy with this in terms of generator. So, but people do, right? It's apparently not difficult to. But in terms of gas, I think if there will be someone interested, I'd like to talk more about it. I'd like to meet people who did this and share if there is someone who wants to share experience as well, it would be most welcome. But yeah, coming back to wood gas. Yeah, so as I said, you can buy it yourself, and there are many different builds, many different methods. You can probably do a workshop on it even without building one. It is actually quite interesting topic, and but first of all, for me, it's a perfect supplement for solar. So just want to say one more thing to all that are actually against. Let's say this is not biomass. It is biomass. Sorry, I should say this is biomass, but it's not the same thing. Even though you're burning wood, you can do it in a way that gasifying wood is basically the cleanest possible way of removing energy from wood. It's basically it has about 95% of efficiency comparing to more traditional methods of burning this. And you can use that gas to generate electricity, which is the most common use, or even to run a car. Like quite a lot of people do that still. So yeah, and why I think this is one of the best supplements for energy in terms of it gives us what solar doesn't. So it can be stable source, right? You start it, it's still based on the batteries, sadly, on the batteries that are actually the key issue. But you start it, you fill up your batteries, you stop it. You don't need to go. It doesn't need to be powered all the time. Doesn't need to be idle like the coal plants when the solar shoots up during day. It solves some problems, right? Especially if you're thinking about community as a source of energy for a community. So there are some commercial examples. I'd rather focus on the smaller ones, smaller builds like this one. The commercial ones are pretty massive. I mean, governments are using this in terms of, let's say, there is some catastrophe problem, and there are multiple big fishes actually using this stuff. So even though it's not much heard of. Yeah, and another thing, as I said, this is to be used primarily in the winter time. So if you are so basically, if you are still heating your house with wood during winter, the heat from this process can be reused too to basically heat the house or or provide you with hot water. So you're not only making energy, you're making hot water, you're heating up your space, and the just to show you how little or a lot, I don't know, you need actually to produce enough energy. So according to the sources I found, you need 1 kilo of wood, but any wood. It could be branches, could be, you don't need to chop down the trees basically. So you need 1 kilo of wood to create 0.7 kilowatt of energy, of electrical energy. So it means for a low, as a supplement to solar, you wouldn't need much more than 2, maybe 3 kilos of wood per day. Which, if you are using a stove in the house, it's not that much. And as I said, in the same time, you're getting the heat back as well. I would stop here. I just want to show you some cool, I guess, builds. They really vary. So some people are doing this from basically nothing. So from rubbish, as you can see, there is like some old radiator on the picture in the left top, old radiator bucket, and I'm not even sure what's the rest of the stuff, but I was reading the article that this guy, his blog, he basically used all he used here was either free or he got it from someone for nothing. In the kind of it's called, but in the background there is a standard petrol generator, and it doesn't really matter if it's petrol or diesel, because the way you supplement, the way you supply gas to it is via the air intake, so it's a little bit different. But there isn't even a need for any modification. But it is simpler if you do. But as I said, this is not the topic for this conversation. So I just want to show you that people are doing this. Yeah. So they are doing this at home. The build on the left is basically it's the same thing. It's just it looks better. It's more professional. And the guy on the bottom one, he drove, I think, from Arctic Circle in Sweden down to the very bottom of Sweden. Took him a few days though, but he and his camper van all was powered by wood, by the gasifier that he had installed. So yeah, that would be all, guys. There is more to come. Also, I want to mention one thing. One of the reasons for me presenting this today, apart from sharing the I hope experience and knowledge I got, because 2 years ago I started with nothing, and as I said, I'm one step closer to energy independence. For me, I'm still looking for a better and cleaner way to do it. And as I said, I welcome any feedback, and I hope we can collaborate on something too. We can create something together that would, benefit us, benefit the environment that we live in, our communities. And so one of the reasons for this is basically to share but also I would encourage everybody to do the same, to basically come up with any ideas that you have that you might want to try, and maybe, you know, let's build something together. Thanks, guys. Do you have any questions? Are you there? Yeah.
Yes. Yeah.
I was wondering.
Yes.
Still someone is, you know, awake.
Chris is already saving energy.
Yeah.
Yeah. Exactly.
By the way,
maybe-
guys, sorry for the
Yeah.
a bit unprofessional way. You know, as I said, I had visitors meanwhile and some noises in the background. Whatever I'll do next, I'll try to prep a little better. So yeah, apologies.
So maybe I will start this. I don't know. I have so many questions, man. Yeah, I just noted like 10 or 15. I think that is just overkill. But thank you for the
Okay.
inspiration. That's the thing. Yeah, because I wanted to actually build some kind of solar build here, but at some point I just resigned. I don't know if it was a good choice or not, but I think that the biggest deterrent for me was the cost of the battery, actually. Yeah, and then I said, okay, that doesn't make much sense. But what I really appreciate in your talk was actually in the very beginning, and you said that what matters here when you kind of convert your life to solar or whatever, basically different kind of energy, is actually the lifestyle that you have. And you mentioned it later, and it's very important for me because I'm not a very big proponent of so-called renewables. Yeah, but what I think is that the step that you are making, it's making you aware of where is this energy going, you know. And when we talked before this conversation, it was obvious for me that now you really understand how energy consuming is actually sending an email. Yeah, so this is the thing that you need to remember, that okay, this would cost me this one, and this could cost me this energy, and then you start to think. So I think that, you know, even taking this step brings you down with your consumption, and this is very, very important thing. So I would like to thank you for showing this. Yeah, and then also I've never heard of gasifying wood, you know, but what you're saying is revolutionary for this part of land that I'm living on, because we've got a big problem here with people not cleaning the forest. You know, this forest belongs to someone, and you know, we've got a hectare of forest just adjacent to our land, you know, and that guy is not cleaning. It's a very big
risk,
fire risk of fire, and you know, it's close to our land. So now the risk is actually on us. We need to secure our home and stuff. Yeah, so the thing is that if we would use this gasifier, you know, and we just tell the guy, man, we're gonna clean your forest, and he's gonna be, man, that's deal, because cleaning the forest like that costs several thousand euro to just you know, pay somebody to do it, you know. And then what do you do with that heap of wood? You basically burn it. Yeah, and it's a big loss of everything. And you know, according to what you said about the efficiency of the process, like 95% of efficiency is just pure, almost. Yeah, so if you need only 3 kilos of wood, and can you tell me, like, can it be also like leaves and this kind of organic matter, or is it like purely wood?
It can be anything, but obviously each organic compound, not compound, each organic. So for example, leaves wouldn't have the same, wouldn't say the same. Oh my God, I'm missing the word. Efficiency, but it's more about the wouldn't have the same amount of power. You wouldn't get, broadly speaking, you wouldn't get as much from, like, wood is quite dense in terms of the caloric power, Jesus, I'm mixing two languages here, but yeah. So, for example, the calories in and different types of wood would have different values. Oak, ash, the names, the other few names I don't know in English, and they are like, for example, coal would be 100%. They would be like close to 50% in terms of the calories they have, the sugars and the carbohydrates that you can get out from them. And yes, and the funny thing is gasifying, so basically burning with not sufficient amount of oxygen, lower, as I said, well, that's it. It is self-explanatory because, as I said, some of the builds there, they are 95% efficient. But what it means, it's not only efficiency; it is we're less polluting as well. So I think that's what is important here as well. And another thing is, there is a vision as well behind it, right? Because okay, you decide that solar is not a viable option for you because of the cost, because of some different factors, and it might be kind of similar if you will build one gasifier only for you. The problem is they like to be. They don't need to be stationary. They are used. The easiest way to use them is stationary. They are actually used on vehicles, right? People driving those cars with the gasifiers. It's funny. Those builds are everywhere. And I've seen the guys in Poland doing this as well. They have a big truck and basically run on wood. But the most important thing is it wouldn't be expensive. It wouldn't be, because obviously you need elements. You need let's say you need it's quite big. It's quite heavy. It requires some metals, metal to build, etc. Various components. But if you do it in a community, I think it really when it makes sense, because you can ensure the usage. You can make sure that you're actually getting the value that you put it in it. And yes, as you said, you can have. There is a lot of sources of wood which we or other materials we would otherwise, they would basically even pollute more in some cases, right? Like, for example, organic matter might actually produce methane unless you take it and you gasify it. So it's crazy. It can be actually beneficial, Yeah. So yeah.
Can I ask you one more question? When they burn biomass, because I haven't gotten into details of it, but maybe you've seen that movie Planet of the Humans, and
I did.
Yeah,
and I have some.
Yeah. So my question is, like, did they burn wood or did they do this process of gasifying before? And also one question: do you need some, preparation for this gasifying, or is it just you throw it in and?
No, you don't need preparation. Although no, I mean, in theory you don't need preparation, right? But depending on the build, you might be preferring to use different materials. So some builds with small combustion chambers would prefer smaller material. So you might either chop it in smaller pieces, but as I said, it depends on the build. Some builds you can basically put full logs and there is no issues. But to answer the question you asked, I don't know. I don't know if those, you see, one thing that gasifier doesn't like would be wet wood, right? Because along with the gas, it will produce quite a lot of steam. And so that might not be the best idea to input in the electric engine, right? Because it would simply cause corrosion over time. So preferred wood, as in any burning process, is dry wood. In terms of biomass, as far as I know, they burn all. So I'm not too sure if they are, but I don't know if they are gasifying wood or if they don't gasify. it would make sense, but I simply don't know. Yeah.
Yeah, so one more question, because I am very much into DIY stuff and reusing stuff. And you said that car batteries, that lead acid batteries, they are really widely recyclable. And do you
Yes.
know anything about the process? What is because there is a lot of used car batteries, and they end up in some heaps. I've seen lately that one company in Evora is actually buying them. So I connected, maybe they are doing the recycling themselves. And so have you gotten into the details of it and
No.
see? Okay, because
No, I haven't.
sometimes
Yeah.
the recycling is very also toxic, yeah, the process of recycling. But what would I need to think about if I wanted to just use car batteries as the battery for my solar system? Could you just elaborate on it?
Okay. Yeah. So in terms of recycling, I can't tell you much. I wouldn't know how the recycling process looks. I wouldn't know. So from what I read, right? But don't quote me on it. For example, in European Union, this process is quite strict. So they have measures in place to prevent, because lead is actually quite toxic material, right? So they have measures in place, and they have ways to do those things that won't cause harm. But look, that's what we read, right? How it looks in the practice, I have no idea. How it looks behind the doors, right? In theory, in European Union, lead recycling is really good, and it is safe, right? Unless there is some issue, but let's consider normal circumstances. How the process looks, I don't know. Now, you asked about advantages, if I understood this correctly, of using, let's say, a car battery, right? Like, I assuming a new car battery in the solar system.
I was asking, like, of any possibility. I mean, because if you, let's say, use a used one, what do you risk? I don't know. It will, of course, hold less energy, right? But is this risky to use the used one? At some point, I don't know, it's gonna explode like these little batteries. I don't know. Is there any risk of using used ones? Yeah, because I think that I can get into possession a lot of used ones. And what would be the effect of connecting 20 used ones? I know that there is a lot of uncertainty here, yeah, but is there any risk?
Risk as such, if I should say yes, but I've seen problems with batteries. I wouldn't put it in a place where you live. Simple reason: lead batteries, the way it operates, there is gas. The gas. So basically, when the battery gets older, in certain circumstances, it might produce gas. This gas can expand, so it can actually, it wouldn't be an explosion, but it can break, right? Or maybe even cause some type, that type of explosion. It wouldn't set itself on fire, but you can consider this risky, right? I've seen basically swollen batteries, because most of the people here on the boats are using truck or car batteries connected, right? So I've seen an example of, let's say, abused battery, and it was swollen. And so for example, if you will attempt to open this battery, it might actually end up, you might end up with some burns, for example. So I wouldn't say this is really safe. From the other hand, the community that I'm here with is using those type of batteries, oh, I don't know how long. Like this started in 1960s, 1970s, I would say. I mean, even before. I mean, each of us has. We have a battery in a car. We have batteries in different places. I mean, even in the phone. I mean, this is lithium battery. Okay, it's a different chemistry, but we have batteries. And I've never heard of an actual problem. I'm not too sure if this makes you feel better or not. But what I will say also, you can't do one thing. You can connect old batteries, but you can only do it in one circumstance if they were used together before, because batteries discharge on different. And this is actually sad news. This is actually something that we. This is the problem with lead acid batteries, especially. You can't. They might have different chemistry, even though they are called lead acid battery. They might actually have different chemistry, different architecture. Also, they might be vented or not vented, but first and foremost, they might have different wear and tear levels. If you connect, for example, if you will connect 10 batteries and one of those batteries will be dying, this battery will be drawing power from your power bank. So I know people who did this here, and it's working well for them. But in general, I discourage people from connecting different old batteries together. It's usually not a good idea. As I said, one dead battery will basically kill slowly your battery pack. So it is. I know it is. It is. In terms of recycling, I actually, thanks for the question. I will educate myself a bit more in that matter, because I don't know the process really.
Maybe Kaha, maybe you've got some questions, because I've got one more, and I don't want to be
Kaha.
rude and take all the floor.
No, you can go on. No, it was really interesting to me. A lot of new things. I didn't expect that you would go to so much details, especially with those solars. So, but it doesn't seem so complicated. Still, I'm living in a block house in Poland, so I guess it doesn't make any sense for me right now. But those things are good to know, like really interesting.
Yeah.
What's the specific questions from my side?
I think even if that knowledge, let's call it, and well, it is a knowledge, if that wouldn't be necessarily used into a practical build, I think it's still worth to know. So, and another thing, as I said, this is basically for really one scenario. I was looking for places to buy in Portugal. I'm still looking for one actually. And some of the places, you might have different circumstances, but some of the places, the electricity was either really far or it wasn't there at all. So you might actually, you think you found a really good place, and you would like to buy that place, and possibly you can build something in this place, but you have no electricity, and you're thinking, can I actually, is it worth it or is it not worth it to buy that place? And I think, and that's one of the outcomes I hope you got from this. It is worth it, and I think you should buy this place. So so that's like, to whoever had doubts. I mean, they probably still have doubts, but I hope it helps to it would help to make that decision, right? Because 2 years ago, I not too sure if I would buy a place which was disconnected from electricity, right? Because I was thinking, oh my God, I heard people pay 10,000-20,000 euros for the off-grid systems, and it's so complex and etc. But it's not. And of course, as you said, Chris, doesn't look easy for you. Well, maybe I'm not presenting this correctly, but It is really easy.
And what was the school that you were like? Electronics?
Who, me? Yeah, I was. Luis Kawola, Technicum Elektroniczne, yeah, Technical Electronics School. Yeah, I mean, maybe I will also ask one more question, because this is a very big difference when you go off grid or you try to connect to the grid with your other sources of energy, right? And what is the situation like globally right now? What is the normal process of connecting to the grid and using your own electricity? How does it actually work?
Okay, so I basically know. You see, that's a good question, and but that's a very tricky question, mainly because every country has a little different regulations. So, for example, Ireland is different, Poland is different. I have no idea what's Portugal's stance on it. So I can basically explain how it works in Poland, but the main thing is they have already changed that law 3 times. So what if we, let's say we'll do a topic on it, but next year they'll put another legislation on it and the law will be changed. So it is not that I'm not recommending being connected to grid and using solar. It's just it's kind of uncertain because you're basically depending on the deal that you have with the state, and the state can change, right?
I mean,
So,
the source of the question is much easier, because right now I am connected to the grid, and I am still thinking about producing my own electricity. So that's the thing, you know. I could maybe gain from this kind of possibility
yes.
to actually. I don't know. I heard that you can sell that amount of energy that you are not using, and then when you are using, you're getting lower rates. I don't know. So that's the thing. I'm asking, what is the model? Maybe can you present the model that you know? How
Okay.
does it work?
So the last I've heard, okay, I'll present the last I've heard, because as I said, it might have changed now, and maybe someone who's living in Poland might actually explain this better. So there was basically 2 different types of connections: net billing and net metering. One was working in a way. It was, for some people, I guess it was better. So one was working in a way that you're producing energy, solar energy, right? You're pushing this energy, you're using this energy in the first place, right? Then you're pushing the rest into the grid, and the grid acts as your bank. So whatever you pushed into the grid, you can then remove 80% from the grid, right? Which made a lot of sense. I mean, which was actually that sounds like they are stealing your 20%, but it was actually very beneficial. I had a friend who was basically running, like he was basically even heating his house in Poland, in mountains area. He was heating his house with a heat pump. Well, he's still doing this. Actually, this is quite funny. He's still doing this, but the model has changed now a little. Now it's 70%, for example, but he's still on the old contract, so I'm not too sure which. Anyhow, coming back to the point. So you could use this 80%, which was great. He was pushing a lot during summer, and he was taking this back when he needed, right? Really great. But they are now, for example, I have a house in Poland, right? So I was looking into it's connected to the grid. Someone is living there, and I was thinking into actually putting the panels on it. But for example, there is a new way of. So there is another way now. So that was the old way. I'm not too sure which one was net billing and which one was net metering, but the new one is different. So I'm not too sure, for example, which way Portugal works now. The new one in Poland now is you produce energy, right? You are selling energy, but with the problem. So you're selling energy straight away, and then you're buying energy from them. Yeah. So you're producing energy, you are using energy, then you're selling the rest, and then you're buying from. Some people can say, well, that sounds only fair, but it's in practice, it might be actually less beneficial for the prosument, because I think you're called prosument, than the first initial version, because the difference in the rates is actually quite massive.
So do you because for me it's quite attractive, and I have two more questions concerning this. Like, do you imagine that you have built completely without batteries?
Yeah. So when you are connected to grid, this is when you can actually live without batteries, which is, see, I was thinking if I should cover this part in my topic, but as I said, due to changing situation, I might be giving someone an information that will change in a year, and so, and and again, the law in every country is a bit different about it. So it might be researching how it works in Portugal, for example. But I still think this is a good idea, especially if you're able to do it yourself and only get the company to basically connect, because you can do that. Well, you can do that in Poland, right? As I was talking to basically a company that meant to do it on my house, and yes, they would give me a discount if I would basically do the job myself. They will obviously come to inspect and connect to perform the connection. See, in Poland now there is some grants as well if you decide to do it. So it's still expensive. It is still much more expensive than if you would do it yourself. But I think it is beneficial. But you need to have money, right? So and like in my case, I wasn't pushed to that place. So basically, at the moment, there is a single person living in that house in Poland, right? With very low needs as well. So the whole project would be, if I want to make it at scale, if I want to make it proper, it would be an overkill. So I would need to invest a few thousand euros, and this would repay back in a long time. So, but it still makes sense, especially if you do it right. As I said, there is few ways to do those things. So yeah, like as I said, I want to build a house. I want to incorporate the solar panels into the build, so I don't need to spend money on, let's say, a roofing material in that place where I will put solar panels, because it is possible. Obviously, this is not as simple as I make it sound, but it is possible.
So the cost that you mentioned was actually the cost of installation and inspection, right?
Yes. So I think I don't want to. I think this was a 5 kilowatt installation, and the price would be about 4,000 euros, 4.5, if I want to do it through the company, or if I will do it myself, they would lower the price for about, I think it was less than 1,000 euro. So it would be 3.5, for example.
Okay, so this is the installation, and then you pay for the inspection, right?
No, this is the whole package.
Okay, so who is actually, because this is part of my second question, yeah? Is anybody checking that? Because I can imagine that you can be very, very lousy at connecting things. I've seen it many times, even in professionals. And if somebody screws it up, you can burn, right? So is there anybody who's just making sure that you're not gonna get electrocuted during this process? I mean, this is very serious, right? Because you are connecting to the grid, yeah? So there is 220 there, and who is checking if you did it right?
No. So maybe I didn't explain this correctly. I made a shortcut in my mind. So if I will decide to go this way, that I will actually do the project, and the company will basically come first of all, I should say, they will connect this to the grid. I will do the installation on the solar part, right? So they are doing this kind of the connection to the to my fuse box, just to make it. Yeah. So this part would be done by the company, but that's like, it's, I would say.
Okay, so in practice, nobody cares what is behind that spot that they are responsible till. I mean, okay, so this is the fuses, they are just connecting, and then they don't really care in practice what is in your house, or
Okay, so I'm not too sure if I'm getting you right, or maybe I'm not explaining.
So let's imagine that it's not solar but gasifier, yeah, and the thing is that, okay, you
I
say
understand now.
Yeah, all right.
Okay, yeah, this is interesting, actually. This is interesting because no, they wouldn't. So for example, once the build is complete, right? So let's say, doesn't matter who, you or a company, they do a solar array installation. Then let's say you do it. You do the solar panel installation. They are coming. They are checking, right, the voltage. They are checking. Now you have those apps. You can see basically a status of every solar panel. You can see how it's performing. They can basically see if everything is connected well, right? Now they are making the connection to the grid, which you are already connected to the grid. So it's quite simple, right? They are connecting this to the grid. That's it, right? You're signing the deal with electricity provider, and with them, basically you sign the deal with them, they do all for you. You are connected. Now, if you want to push some more energy to the array, yes, you can. I mean, it would need to be within, it would need to be within, let's say you have it's called falownik in Polish. It's basically a controller, but it's like slightly different controller than we discussed before in this topic. Yeah, it's as I said, it operates in higher voltage. It's slightly different, but it's doing the same job. Sometimes there is it has an inverter basically built in, a type of inverter, right? Because it basically transform this energy to 20. But of course you can. So for example, now I have a solar controller, but I have a solar controller with option to connect wind, right? Because I had a wind turbine before. I built this wind turbine, and I was charging batteries with this wind turbine. I have a dedicated controller to do this because and only for that reason, because my build was basically AC build. So I was producing AC voltage, not DC. Hence, I required a different. But in theory, you could connect a wind if it is producing direct current to standard controller and then to your batteries. So what I'm trying to say, if you will make the same type of current, let's say in that case, the solar array is producing DC current. If you will produce DC current within the same range of voltage, yes, you can connect it to your falownik or DC AC inverter / controller and sell the power. So yes, you can basically make your power, sell it, and cash in. But yeah, but does it make sense actually? Because because it's a long topic. Because imagine you will be basically burning your own wood. Let's say the 1 kilowatt costs, I don't know how much it costs in Poland, 80 cents, 50, no. In euro, it costs, I think, 30 cents or 25 cents. So there might not see the problem with the way they are charging us for electricity. Quite a lot is some different charges, right? So the kilowatts, I don't know if it is 50% or 60% of charge, but it's not. There is a lot of other things, yeah. So you would be basically burning, let's say, your own wood, unless you know to. Would it make sense? I don't know.
For me, right now, because I'm super new to this gasifying wood, but for me, it's a game changer, really. I haven't heard of anything like that, and this is a very big problem changer for me. You know, it's like 2 in 1. You know, because at one point I just solved the problem of risk of fire, and then I get a lot of days for free. Yeah, so that's the thing. Maybe let's, because I know that we can continue, but it's been like 2 hours, so I will just try to ask you one last question, because if you see this gradient of awareness of using the electricity, because of 2 years of actually tweaking stuff and doing this manually and reading manuals and watching videos and blah blah blah, what is your like perfect model of living, and what do you think about the exchange of, you know, okay, you live less expensive, and you don't depend that much on the grid and the civilization and stuff, but you of course need to work a bit more to actually get in this state. So what is your goal lifestyle because of doing this? Do you want to become like energy free and you will not use any, or is there some kind of vision for you that okay, at some point I will just stop changing anything and this is going to be my lifestyle? So this is, go on, man.
Well, that's a hard question, and I will try not to go on for another 30 minutes. So I'll try to be brief. No, I don't. Well, first of all, I believe I will never stop. I will never stop in trying to be better. I don't believe. I think I said this in the beginning. I don't believe in free or clean energy. If you transform energy, there is always some losses. You know, physics. You can't break it, and so no, I don't believe in free or clean. But that's one of the things. Yeah, you mentioned this as well. It makes you one of the things. Let's put all the other things aside. It makes you think about energy, how you use it. That it's not free. Like one example, right? And maybe I said it, but one example. I have all the same equipment that a house has. I have 30 square meters here. I know it's not much, wouldn't compare it to a house, but I have all the things that other people has, and I'm still able to consume, let's say, 1 kilowatt per day, and I'm okay with this. I mean, and I have enough. So imagine that median, right? You can Google what's the median, what's the so what's the average amount in Portugal, but everywhere it's between 3 and 5. So how? I mean, yeah, why? Maybe it has to be that high, right? And you can see people, I know this is India or Nigeria, we're comparing this to, but they are living lives too, right? So and from another scale, you look at US and Canada, the daily consumption of energy. I can't understand what those guys are doing with why this is so high. So
Those people are invading other countries, and they've got the electricity much cheaper, unfortunately. So
No, yeah, but still, why the consumption is why
because
this is so
you
different?
can we as humans, we just consume as much as we can. So that I think that if you have this lifestyle, you just adjust your lifestyle to the amount of available energy. I think, yeah, that's what they say everywhere. Yeah, that unfortunately we use all the pie. Yeah, that's even if we try to get those fossil fuels, just get rid of them. No, we still use them because we are adjusting to the available amount of energy, not to the amount of energy from a month ago. Yeah, so that's I don't know. I don't understand it as well, but I understand that people, okay, if you pay 2 cents for kilowatt, you're gonna use accordingly. Yeah.
Maybe. Yeah. Yeah. Look, so for me, this is a journey, and as I said, that's one thing. Another thing is, I believe working alone or doing things alone sometimes also makes no sense, because even the battery thing, right? Okay, this is another conversation. This is a long topic, I guess, but we wouldn't necessarily need to, like, everyone has a separate battery. This could be done differently in some cases, in some communities as well. And even that thing as a gasifier, you're cleaning land, you're producing energy, but you're feeding this to your neighbors as well. It's free. You started the gasifier. Why would you finish before all the batteries are full? But yeah, but as I said, that's for another. Yeah. So yeah, so for me, that energy, this, mm, it's a journey, right? It's I got here, but I want to go further with this, and for a lot of reasons. Yeah, I think, yeah, as you said, um,
Yeah. I think that
every
is very, very important what you just mentioned, that this can be a very communal effort. And maybe I will just try to wrap it up, because I think that the power of those presentations that we are just doing here is the community behind it. Yeah. So I would like to encourage everybody who watches it to just ask Krzysztof questions, yeah, and maybe go into some projects together. Maybe Krzysztof can advise you on something. The power of it is that Krzysztof is the one of the member of the community here, and why not making something huge together and good, and save the energy and come up with something very original, make another step in our progress to yeah, to just be really sustainable. Yeah, that's the thing.
Mhm. Yeah, yeah.
Thank you very much for the presentation. I'm very grateful for all the information. It is really a lot of knowledge behind it, and now I think that I'm not lost in it. You really structured the thing for me. Thank you very much.
No problem. You're welcome. Yeah, so guys, I say we'll wrap it up. I need to finish. My wife is waving to me. I think she made some food and it's probably getting cold. So yeah, so it was a pleasure. It was a pleasure, and I hope we will do something together, or we'll participate in thoughts exchange and brainstorm a bit more on it as well. So yeah, I hope to see you again soon. Have a good night.
Thank you.
Thank you.
Ciao from the boat. Yeah.